All right, guys, let's look at lesson 3, which is structural formulas. There's 3 types of formulas that we come across with organic compounds. The first one is a molecular formula, and it shows the number of atoms of each element in a compound, and it's the least informative formula. So that would be just, for example, C2H6. Then we have a structural formula. It's the diagram of the molecular structure of a compound. So we have 2 carbons. Each carbon has 3 hydrogens around it, and then they're bonded to each other. Then we have the condensed structural formula, which is each carbon is written separately, followed by the atoms bonded to it. So this will tell you that this carbon has 3 hydrogens around it, this carbon has 3 hydrogens around it, and then the 2 carbons are bonded together. So the condensed structural formula is easiest written after we write the structural formula. So drawing structural formulas for alkanes. You're going to use table P and table Q to determine the number of carbons and hydrogens. And remember, each carbon must have 4 bonds. So, for example, what's the formula for methane? Okay, so we're going to go to table Q. Meth means that you have 1 carbon, and so we have to remember what our formula is going to look like. And so our formula is going to be CH4. The structural formula is going to have a carbon in the middle with the 4 hydrogens around on the outside, because we need 4 bonds, each bond connected to a hydrogen. And then the condensed structural formula is actually going to look just like the molecular formula, which is CH4, because we only have 1 carbon in this case, and we have 4 hydrogens around it. Okay, what about ethane? So the molecular formula for ethane is going to be C2H6. Eth means 2, so it'll be 2 to the, to get our number of hydrogens, it's going to be 2 times 2 plus 2. So we have 2 carbons, and they're going to be bonded to each other. And then each carbon is going to have 4 bonds around it. So, and each of those bonds is going to be attached to a hydrogen. And then our condensed formula is going to show that we have 2 carbons, and each carbon has 3 hydrogens around it, which is what our actual formula for ethane looks like. What if I asked you for this practice problem to draw the formulas for propane? I want you to try this. So you need to draw the molecular formula, the structural formula, and the condensed structural formula. So pause the video and unpause when you're ready. Great, well, what did you come up with? Well, for the molecular formula, you should have come up with C3H8. For the structural formula, you should have 3 carbons in a row with 8 hydrogens around it. And for the condensed formula, you should have C with 3 carbons attached to it, another C with 2 hydrogens attached to it, and another C with 3 hydrogens attached to it. So C3, C2, C3, H3. So what about if we're drawing structural formulas for alkenes? They're going to be the same as alkynes, except there are more than 3 carbons, so you need to give the location of the double bond. You're always going to start numbering carbons at the end closest to the double bond to give the bond the lowest number. So for ethene, okay, if we're looking at the molecular formula C2H4, and the structural formula is going to have a bond in between both carbons because it's ethene, so we have to have a double bond. And then because we add that double bond, we can remove a hydrogen from each carbon because each carbon only needs to have 4 bonds. And if we add that double bond between both carbons, then we have our 4 bonds. So then our structural formula is going to be CH2, CH2. What about for propane? For propane, the molecular structure is going to be C3H6. So we're going to start off with propane, and we're going to put a double bond in between 2 of the carbons. And then we're going to fill the rest of those bonds with hydrogens, making sure that each carbon has 4 bonds around it. And then our condensed formula is going to be CH3, CH, CH2. So what about 1-butene? Okay, remember, butene is 4 carbons, so it'll be C4H8. If it's 1-butene, we're going to start numbering our carbons from the furthest end, and so that's going to be the double bond could be here, or it also could be on that side. So in this case, we're numbering 1, 2, 3, 4 is where our numbering is going to be, and so in between the first and the second carbon is where our double bond is going to be. And then our condensed structural formula will look like this: CH3, CH2, CH, CH2. All right, let's draw the formulas for 2-pentene. Pause the video, unpause when you're ready. When you did this, you should have come up with a molecular formula C5H10. Your structural formula should look like this, and you should have a double bond in between the second and the third carbon because it's 2-pentene. So this is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. And our condensed structural formula is CH3, CH2, CH, CH, CH3. What about for isomers? Isomers are compounds with the same molecular formula but different structural formulas. They have different properties, and the more carbons you have in your structure, the more possibilities you have for isomers. So when we draw an isomer, that's exactly what we're doing. We're going to use the same molecular formula but arrange the atoms in a different structural arrangement. So both of these examples I have here are both for C5H10. This one has the double bond here, where this one has the double bond here, but they still have 5 carbons, 10 hydrogens. So what are 2 isomers of butene would be our example. So we can draw 1 butene here, or we could draw 2 butene here. Those are 2 examples. That double bond can move. It's not stationary. It doesn't have to stay in that one place. So drawing structural formulas for alkynes, they're going to be the same as alkenes, except you add a triple bond. So for 1-butyne, our molecular formula is going to be C4H6. Our structural formula is going to look like what butene was, but we're going to add a triple bond. And when we add that triple bond, we have to take away 2 hydrogens because our carbons can only have 4 bonds around them. And then that would be 1, carbon 2, carbon 3, carbon 4. And our condensed formula will be CH3, CH2, CCH. Okay, what about for a practice? Draw the structural and condensed formula for 2-pentyne. Okay, pause the video, unpause when you're ready. Well, the molecular formula for 2-pentyne is C5H8. So our structural formula is going to look like this. Okay, it's the second carbon, and that's going to be our condensed version. All right, we're going to look at this, check your understanding first thing in class tomorrow. Have a good night.